Penn State Mechanical Engineering Design Methodology course, also known as ME340, has tasked us with designing an autonomous line-following robot. More specifically, the robot in question is required to follow a track autonomously. It has to do so rapidly, it has to be robust to interference, and it must possess a unique feature. After a lot of group discussion and careful consideration with our team, we decided that we want to make a robot with metal detecting capabilities. We think that a metal detecting robot could be pivotal in mitigating the increase of ocean pollution, and we're really excited to share our findings with you. The main message that we want to communicate in this video is that in order to yield a fully functioning robot which meets the speed and autonomy requirements, we want to make sure that we conduct a lot of series of tests regarding wheel design, chassis geometry, and IR sensor placement, as well as additional circuitry. For starters, we produced 5 iterations of our wheel design. This allowed us to improve the robot's stability and navigational accuracy while also minimizing the amount of added materials necessary to fabricate the wheel. We ultimately landed on a design with 4 curved spokes and 1 exterior track for an O-ring. The spokes provide enough support to secure the robot, and the O-ring creates traction between the wheel and the ground so that the robot can turn promptly. The design of the spokes also significantly decreases the amount of material necessary to put the wheels. This will definitely save money in the long run. The final structural advantage of our robot that we wanted to discuss before delving into the technical aspects of our software is straightforward. The IR sensors and our metal detecting ring have to be positioned very closely to the ground. Research indicates that when both IR sensors and metal detectors are positioned closely to the ground and their intended targets, their readings become more accurate.
Our code used if-else statements with digital readings, high or low. We had 3 sensors initialized in our code. When the left and right sensors read high or black, the robot would travel straight. When the left and center sensors read high and the right sensor read low or white, the robot would turn right. When the opposite sensors would read high, the robot would turn left.
So once we had our first 2 prototypes, it was now time to try to make the robot as small as possible and condense it, because with a smaller robot you have a tighter wheelbase, which makes the robot more maneuverable and faster, which at the end of the day is what we're trying to do in order to compete with our other classmates. So doing this, the key was to take the 2-dimensional acrylic design that we had in the Alpha 1 and Alpha 2 and make it more 3-dimensional. And with this, it came with a lot of thinking, but the design that we found to work the best in our situation was a vertical Arduino, because a lot of the wires for the 2 breadboards that we used came from this Arduino. So we had a vertical Arduino with the breadboards in the front with the IR sensor and the metal detector, and then the heavier components in the back, the heavier components of the batteries in the back on the axle itself. So a lot of the heavier force is directly in line with the wheels.
Lastly, you should consider approving further development of our product because our unique design feature is ambitious and effective. A Tinkercad which represents the design of Team 1-1's unique feature can be observed in the figure shown. As can be seen in the image, the circuit is comprised of a buzzer, an LED light, 2 resistors, a capacitor, and a copper coil. The components must be arranged on a breadboard in the same fashion presented in the figure. When metal is detected, the LED will emit a light and the buzzer will generate a noise. To accurately detect metal, we adapted and uploaded the code script to the Arduino Uno, which the circuit is connected to. A skeleton of the code script can be seen in the image shown.
All in all, we are incredibly proud of the design and prototype of this product. We'd also like to thank you for the consideration of furthering the production of our autonomously metal detecting robot.